Good afternoon, student. So, last class you have seen about total internal reflection. So, today I am going to show some uses of total internal reflection. So, one of the example is total reflecting prism. So, what is the total reflective prism? You know already prism there is two triangular shape and three rectangular shapes. Clear? And normally the front side we are used to discuss about the front side. If the angles of prisms are 90 degree, 45 degree and 45 degree, that type of prisms are called as total reflecting prism. So just the two sides are equal, that is isosceles, and other angle this one will be 45 degree, this one also 45 degree, and this angle will be 90 degree. This type of prisms are called as total reflecting prism. So you will get some ray diagrams, they will ask you to draw. Now, by using this total reflecting prism, we can deviate the ray, the deviation of ray by an angle we can do by 90 degree, then we can do 180 degree, we can do, so normally we are showing this one only, 90 degree, 180 degree, we can erect the image also. So let's see first one by an angle 90 degree. So now see, if the ray comes in that way, that perpendicularly to the surface, it fall here. So now if this one is 90 degree, this angle also will be 90 degree, this one is already 45, so this angle also will be 45 degree. Now if you draw one normal, so the angle of incidence I is 45 degree. As we know that if I is greater than IC, that is critical angle, there will be total internal reflection. As you know, again I equal to R, that means by an angle 45 degree it will reflect back here totally. So now the ray is supposed to go in this direction, but it changed this direction. So this angle, this one is also 90 degree. That means the deviation is by an angle 90 degree. So same one you can draw for 180 degree also. This one is 45, this one also 45, this one is 90 degree. Now if a ray comes, there as it is 90 degree, again it will change and it will change in direction in that way. So this is an implication. So now how you know it is greater than critical angle? You know that for a glass, the critical angle is 41.1 degree, or sometimes they used to use approximately you can use as a 42 degree. So as you know that 45 degree is greater than 42 degree, so there will be total internal reflection. So now one application is there that is called periscope. You know, everyone knows about periscope. Normally in periscope we used to use mirror, so that if you keep your eye here, from an object, if ray comes, by reflecting you can see the object. Now if I replace this mirror by a prism, if I replace this by prism, so which one will be better? This one is the normal reflection, there will be total internal reflection. Now you can tell which one is better. As I told, the total reflecting means total internal reflection means there will be no absorption will be there will be 100% reflection. But in this case, as it is a plane mirror, there will be little bit 1 or 2% absorption will be there. That means in second case the object will be more clear. So we will prefer total reflecting prism for use in periscope. Clear? So there is another phenomena is there, what is called as brilliancy of diamond. Why diamond look like sparkling? Correct, there is a brilliancy. The diamond they cut in such a shape, if you consider one diamond, in such a shape they cut the diamond, whenever a light enters, it get reflect back because they fall greater than critical angle. So the continuation reflection going on inside the diamond. Due to that, it look little more bright, it's like sparkling. Okay, that is the phenomena of brilliancy of diamond. Another interesting phenomena I will show you, that is called circle of illumination. Circle of illumination. Circle of illumination. So what is that? Now inside water, if you keep one bulb, what will happen? From the bulb, each every direction light will come out. So which one is coming? This one is, you know, that one is air, this is water. So the refracting index is greater here. If one is N1, this one is N2. You know that N2 is greater than N1. Now it will come here. Again, there also some layer of light will go. As it is coming from denser medium to rare medium, it will bend away. It will bend away. It will go on. Slowly, you can find such an angle. After that, it goes along the side. More it goes, it reflects back because of total internal reflection. So you can see that you will imagine one circle there. Through this circle, the lights are coming out. You don't think like there is a for every light will come out. So there will be a particular circle in between which the lights will come out, though there is a bulb. Clear? So that is called as circle of illumination. You will see like that from there lights are coming out. So that one will find out the radius of circle. So now again if you draw, let's consider this one is height, this is the radius of circle. Now here IC will consider as a C. So this is the angle C. See, this angle is greater than critical angle, this one is C here. So from this angle, from this diagram, what you can write? Tan C equal to perpendicular by base, that is R by H. From here you can calculate R equal to H tan C. Now we need to find out the tan C value. Now for critical angle we know that sin mu equal to 1 by C. Sorry, sin C equal to 1 by mu. Last class I have shown. From here you can draw one triangle. You know that sin means perpendicular by hypotenuse. Perpendicular is mu, hypotenuse perpendicular is 1, this one is mu. So we can find out base root of mu square minus 1. Now we can find out from here what is your tan C. This is the angle of C. So tan C is perpendicular by base, that is 1 by root of mu square minus 1. If you apply this value here, you can find out H into 1 by root of mu square minus 1. That means R is root of mu square minus 1. This is the value of the radius. You can find out the radius of circle of illumination. So this one important topic. Now we will find out some atmospheric effect, some atmospheric refraction also we will see now. For an example, it is there in the book. We will go for atmospheric reflection. the shift of position of sun during sunrise and sunset. So, if you consider this one is the earth surface, you are standing here, you are standing here, there is ice. So, the sun during the sunrise and sunset, the sun is here. So, there are layers of air, you know already. There are different layers are there. As you go above, the density will decrease. The density decrease. That means this one will be mu1, mu2 like this. This one will be rarer medium. This is more denser, more denser, more denser, more denser going on. Now, if the light comes from here, as you know, it going from which one? It will going from rarer medium to denser medium, or it is denser medium to, sorry, it is density increases, not decreases. The density will increase. So it is going from rarer medium to denser medium. What will happen? Or denser medium to rarer medium. What will happen? If it goes from denser medium to rarer medium, so there will be again, it will bend away. It will bend away. Now, when it will bend away from this one, if going denser medium to rarer medium, it going bends away. In this particular medium, the angle will be more than critical angle. Again, it will reflect back. The way it's gone, same way it will reflect back. Now, this person will see the light is coming from here. That means you will see the apparent shift. The sun during sunrise, sunset, sun already down, but you will still see that sun is there. Clear? There is the atmospheric refraction. Another interesting one is mirage. Mirage. In desert area, when there will be one tree, there are also layers of air. So the layer which is near the ground, that will be air medium. Clear? It will be rare, there will be more dense, because why? Because the surface near this one is hot. So the density of air will be little bit less, then will be more, then will be more, then will be more. Clear? So now, if light comes from here, it is coming from denser to rarer medium, it will bend away. It will bend away. Now, if it is for more than critical angle, what will happen? Again, it will reflect back. This one person is coming here, suppose your eyes are here. You will see the image of this tree reverse. And as you know that airs are flowing, you will see that this image also moving. So, you will see one illumination that maybe there is a pond is there, that's why the shadow of the trees are there. So, more if you come near to this one, suddenly you will find that there will be nothing is there. So, that illumination is called as mirage. Clear? So, more examples are there in your book, looming also there. So, you just study from there. This is for the atmospheric refraction. Next, nowadays, one important topic is there, that means application of total Indian reflection. One network or one transmission system is there, that is called fiber optics or optical. So this one is used for transmitting of data. This wire is used for transmission of data or signal. What are the signal? Light, audio, video. The signals we can send through fiber optics. So actually, what is fiber optic? So this outer part of this fiber optic is called as cladding. They are made up of two different material, and the core inside one is called as core. They make in such a way that the refractive index, this one is considered N2, this one is considered N1. So in such a way that N2 is always greater than N1. Now, if a light enters here, from air, as you know, air also is a rarer medium, it's constant denser medium, it will bend towards the normal. So it will fall in such a way the inner surface of cladding and this one core, this angle will be more than critical angle. So there will be total internal reflection takes place. So as you know, if there is total internal reflection, there will be no absorption. So the data, whatever you are sending, it will reach to the receiver very nicely. So this is the one of the application. So there are some advantages also. So more advantages are there in your book. That means it is very useful. There is less absorption, 100% successful, correct? 100% reflection is there. These are fiber optics. Now we'll go for another important topic, your ray optics, that is called prism. We'll study on prism, how the reflection takes place. So already I told you what is prism. Now so this one is called as angle of prism. We can consider as A. This one is base. Now if a light ray fall on prism, this one is I1. It's supposed to go in this way. This is the original path. N1. This one at N. This one is 1 because air refracting index is 1. Let's consider the refracting index of glass is N. So as it is coming from rarer to denser medium, it will bend towards the normal. This is the normal. It will bend towards the normal. Again in this condition, it is coming from denser to rarer medium. Here you can draw one normal. Again it is supposed to go in this way. It will bend away from the normal because it is coming from denser to rarer medium. So this one is I2. We can consider R1, R2, OA. So this one is called as deviation. This is from the original path, how much is deviated. We are going to find a relation between that. Now, if you see here in this direction, this triangle PRQ. This one is I, this one is R, the remaining one you can find out, I1 minus R1. Same to same, this one you can find out, this is I2, you can find out this position as I2 minus R2, and this one is del. So what is the relation between that? Del is, we know that the external angle is sum of internal angle, so you can find out I1 minus R1 plus I2 minus R2. By opening bracket you can find out I1 plus I2 minus R1 plus R2. And if you see this rectangle A, P, O, Q, this one is 90 degree because this is a normal, this one also 90 degree, this is a normal. So this angle is A. So what is the value of this one? You can find out. If you consider this one is O, you can find out from there A plus O equal to 180 because total is how much? 360. So this one is already 90, this one is already 90, 90, 90, 180 cancel. So A plus O is equal to 180 degree. And from this another triangle, that is POQ, this one is R1, this one is R2, this one is O. Here R1 plus R2 plus O equal to 180. Now if you compare these two, they are also R1 plus R2, there is A. So you can write A equal to R1 plus R2. Now if you substitute the value here, you will get delta equal to I1 plus I2 minus A. So sometimes this I2 they is to consider as an angle of emergence E. So you can write down delta equal to I plus E minus A. So this is the value of deviation D. Now, what are the factors on which the angle of deviation is depend upon? The first factor is what is angle of I. I means the angle of incidence. If you change this angle, the deviation also will change. The second factor is the angle of the prism. If the angle of the prism also will change, it will change. And the last factor is the refracting index of the material, which material you are using, and the wavelength of light. There are the four factors are there on which this angle of deviation is depend upon. You have learned before also, if it is there. Now, if you want to find here Snell's law, if you are going to use here Snell's law, what you can write? 1 into sin I1 equal to n into sin R1. So from here, what is your n value? Sin I1 by sin R1. Same to same, if you go for the second surface, you can write n into sin R2 equal to 1 into sin I2. From here, n equal to sin I2 by sin R2. So it's a very important relationship. Now, one question is to come for minimum deviation, for angular prism for minimum deviation. This one you remember, we are going to use this. So, if you draw a graph or curve between angle of incidence versus delta, I versus delta, by taking delta along y-axis and I along x-axis, you can find the graph in this way. So, wherever if you, for delta if you draw, so there you will get I1, there you will get I2. So, we will to find out the minimum deviation. So, this is the position of minimum deviation. If you draw from here, this is the position of minimum deviation, where you can consider as a I. That means I1 also become I, I2 also become I. If I1 also become I, in that condition R1 also become R and R2 also become R. Now, what is the value of A? We know that the value of A is R1 plus R2. That means R plus R, that is 2R. From here we can find out R equal to A by 2. And from D we know that I1 plus I2 minus A. So from here, if it is become delta minimum, we can find I plus I minus A, delta M equal to 2I minus A. From here we can find out I equal to delta M minus come here plus A by 2. So this value, if you substitute in the formula, what is n equal to sin I by sin R, the formula will become sin delta M plus A whole divided by 2 by sin A by 2. This derivation is to come in the exam. Clear? This derivation is to come in exam. This is a very important one. So the same value you can find out for small angle prism also. For small angle prism also, we will be able to find. So what is small angle prism? The small angle prism means the angle of prism will be too small. The angle of prism will be too small for small angle prism. This is the deviation B we are going to find. So now for the first surface, what do you know? We know that n equal to sin I1 by sin R1. As the angle is too small, as the A is too small, we can write down sin I1, we can write down almost equal to I1, and sin R1 we can write down almost equal to R1. From here we can find out I1 equal to N R1. And same to same you can write down N equal to sin I2 by sin R2, I2 by R2, because it is too small, the angle is too small, that's why sin I2 almost equal to I2. From here you can find out I2 equal to N R2. Now, what is the formula for D or delta? Delta we know that I1 plus I2 minus E. So, if you apply the value here delta we consider as D, I1 value is N R1 plus N R2 minus A. If you take N common, R1 plus R2 minus A. We know that R1 plus R2 value is also A minus A. So, this formula will become N minus 1 into A. The value of angle of deviation through small angle prism. Clear?